Deadlocks. Unit 4. डेडलॉक्स में क्या है? कैरेक्टराइजेशन ऑफ अ डेडलॉक, म्यूचुअल exclusion condition, hold and wait condition, known primitive condition, circular wait condition. Dealing with deadlock situation, deadlock prevention, deadlock avoidance, deadlock detection and recovery. Okay, ये है. Introduction to deadlock simplified. In any computer system, there are limited resources like printer, memory, CPU, time, or files. These resources are shared by many processes. Before a process uses a resource, it requests it. If the resources is available, the process uses it. After finishing the process, release the resources so other can use it. The operating system manages these processes of allocating or freezing resources. Deadlock explained with a story. Imagine two friends, Alice and Bob, who wants to use two different things, a phone and a laptop, but each needs both to finish their work. Alice already has the phone, Bob already has the laptop. Now Alice wants to use the laptop, but Bob won't give it until he gets the phone. At the same time, Bob's wants a phone, but Alice won't give it until she gets the laptop. They are both waiting for each other to giving up the resources, but neither will do it. Alice is waiting for the laptop Bob has, and Bob is waiting for the phone Alice has. Because neither gives the resources, they both get stuck. This is deadlock. Okay, why is this important? Both are holding a resources the others want. Both are waiting for the others to release it. No one can move forward or finish their work. How to remember it? Think of Alice and Bob with phone and laptop stuck is a resource grab. Two friends, two things, both waiting for other to let go is deadlock. Two friends, two things, both waiting for the others to let go. Another quick example, the traffic jam. Imagine a narrow lane bridge where cars are coming from both sides. A car from the left want to cross, but is waiting for the car on the right to move. The car on the right side to cross but is waiting for the car on the left. They block each other and none can move forward. This is called deadlock. Deadlock simplified. Resources. There are two main kind of resources in computer system. Primitive resources. These can be taken away from a processor safely. Non-primitive resources. These cannot be taken away safely while a processor is using. What is deadlock? A deadlock happens when a group of processes get stuck because each one is waiting for something that only another processes in the group can give. Imagine a group of people sitting in a chair, each holding a key that the next person needs, but no one wants to give up their keys. Everyone is stuck and no one can move. Example 1. Process 1 has drive. Process 2 has a printer. Process 1 needs to print the continue and process 2 needs the tape drive. Both are waiting for other to release their resources, so they get stuck forever. This is deadlock. There are 3 disk drives and 3 processes. Each process holds one disk drive but need another one to continue. All 3 wait for the other to release their disk drive. They all get stuck in a deadlock. Where do deadlock happen? Usually in system where many programs run at once, like multitasking system or client server system. Deadlock are also called deadly embarrass because processes are stuck holding each other. How to solve deadlocks? Sometimes the system or the program try to fix the deadlock but does not always work. Okay. Deadlock characterization, the 4 Kaufman condition. For a deadlock to happen, these 5 conditions must be true at the same time. Deadlock characterization, the 4 condition. For a deadlock to happen, these 4 conditions must all be true at the same time. Even if one condition is missing, a deadlock will not happen. Mutual exclusion, meaning some resources cannot be shared, only one process can use them at a time. For example, a printer, only one process can print at a time. If someone else wants to use it, they must wait. Only one person can sit on the printer throne at a time. Hold and wait. It also only one process can print at a time. This example means some resources cannot be shared, only one process can use at a time. Hold and wait, meaning processes is holding at least one resources and waiting to get more. Process A has a pen but needs paper, held by process B. Process A won't let go to the pen and waits for the paper. Hold and wait. A process is holding at least one resource and waiting to get more. Process A has a pen but needs paper, held by process B. Process A won't let go the pen and waits for the paper. Hold one, wait another. No permission. You can't forcefully take away a resource from a process. It must release it on its own. Example, it's a process has a file open. If you can't just take it, it has to close it by itself. No snatching allowed. Circular wait. There are a circular chain of process. Each is waiting for resources that the next one in the circle has. Process A waits for a resource B held by B. B waits for resources held by C. C waits for resources held by A. Now they are stuck in a circle, waiting in a circle forever stuck. Common example, traffic deadlock. Imagine 4 cars at a 4-way intersection. Each car is the one section of road. Each car wants to move forward to the next section. No car can be moved or pursued. Example, traffic deadlock. Each car is in one section of a road. Each car wants to move forward to the next section. No car can be moved or pushed away. Every car is waiting for the next one to move. All 4 deadlock conditions apply. Mutual exclusion, 1 car per section. Each car hold its section and wait. You can't force a car out. Car waits in a circle. How to remember? Okay. My hot noodle cook. mutation, Hosen weight, no perimeter, circular weight. Resource allocation graph. Resource allocation graph, RAG. A resource allocation graph is a visual tool used to understand and detect deadlock in an operating system. Two types of nodes: processes shown as circle, resources shown as rectangles. Dots inside rectangle shows that how many instances of a resource exist. What do the arrow means? From process, resource, processing, or waiting. How does RAG help detect deadlock? We look for circle loops in a graph to detect deadlocks. No circle, no deadlock. Everything is following fine. No one is stuck. Cycle plus one instance per resource. Deadlock has definitely occurred. Since each resource can't be shared and the circle shows everyone waiting for each. How to deal with deadlock? Prevention, avoidance, detection, and recovery. Deadlock prevention. Stop deadlock before it happens by denying one for the four deadlock. This condition is based on Havender's algorithm, which tries to break one of the four deadlock. Let's eliminate mutual execution. Don't allow resource to be non-shareable. Real world example: make files read only so many processes can access it at the same time. Not all resources can be shared, so this is not practical for most cases. Eliminate holds and wait. Don't allow holding one resource while waiting for another. Ask for all resources at once before starting. Don't allow new requests if already hold some. If a process needs 3 printers and 1 scanner, it must ask for once. If all not available, it waits until problem. Eliminate no primitives. If the processes can't get all it needs, take away what it already has. Eliminate no preemption. Example: processes A holds printer and wants scanner. If scanner is not available, take the printer away from A so other can use it. Problem: the process may lose all its progress, can lead to starvation. Eliminate circular waits. Force all resources requests to follow a mixed order. Deadlock avoidance. Be careful before you say yes. Deadlock avoidance means think before you give resources. Avoid going into a deadlock by checking if it's safe. Go to give the requested resource. Imagine a banker. This is why it is called banker's algorithm. Banker's algorithm. Just like a banker does not give out a loan unless they know they can serve all customers safely. The operating system does not give resources unless it is sure every process can finish eventually. Key concept: each process tells upfront how many resources it may needs to most. The OS checks if I give resources now, will system safe. Deadlock detection recovery. Let it happen and fix it then. Unlike prevention and avoidance, this method allows deadlock to happen, then detects it and fix it. Deadlock detection: spot the stuck processes. How detection works: start with unblocked processes. Assume they complete. Now check if someone blocked processes can process with those release resources. If many processes are still blocked, deadlock detected. How detection works: start with unlock processor, assume they complete. How to check if someone block processes with those release resources. Repeat step. Deadlock recovery. Once deadlock is found, the system recovers using one of these two methods. Processes termination. and some of the deadlock processes until the cycle breaks. Termination is done based on process's priority, how much work is done versus remaining, how many resources the process is using, how processes can cause damage if kills. It is an interactive process, easy to implement. Checkpointing and rollback. System takes checkpoints during execution. If deadlock happens, rollback process to last checkpoint. अच्छा, हम डन। अब इसको देख लेते हैं। समरी। A deadlock occurs, a process has some resource and is waiting to acquire another resource. While that resource is being held by some processes that is waiting to acquire the resources that is being held by the first processes. A deadlock needs 4 conditions to occur: mutual execution, hold and wait, non-preemption, and circular waiting. We can handle deadlock in 3 major ways. We can prevent them, handle them, and we can detect them and simply ignore the whole deadlock issue altogether. Done.